Hello, good day viewers. Still on the Riemann sums. Today we are going to compute the Riemann sums for the function x to the power of 3 on a given interval 0 to 2, where n is equal to 10. Remember that n is nothing but the number of rectangles. So first of all, I would like to show you how this function looks like. Suppose we have y-axis and x-axis like this. This function looks like this. So you want to find the area under the curve between 0 down to 2. If suppose this is 1. So we would like to compute for the area within this region from 0 down to 2. So this is the region we are talking about. But remember, according to Riemann, you have to inscribe some rectangles of equal bases. So here we are going to inscribe 10 rectangles here. We inscribe them here, here, here. We have to fit with 10 rectangles within this interval 0 to 2. And how do we do that? First of all, we need to compute for the base of each rectangle. And remember that area of a rectangle is given as what? Base times its height. So this is how we're going to do that. Because they have equal bases, to compute for the base, which we call the x, delta x, this is equal to b minus a divided by n, for which b is the higher limit, a is the lower limit, n is the number of rectangles, because we are going to share that interval equally. So this is equal to 2 minus 0 divided by 10, because we are having the limit 0 down to 2, right? According to the question. And 10 stands for the number of rectangles. So 2 minus 0 is still 2 divided by 10. This will give us 1 over 5. And 1 over 5 can also be written in decimal as 0.2, right? So let's use 0.2 as our base. So to find the corresponding heights, I'm going to use number line. I think it will be better. And we are going to compute for this area in 3 different ways. The left Riemann, the right Riemann, and we're going to take the midpoint. So let's start with the left Riemann. Remember the endpoint, we have 0 and it has to stop at 2, right? So we are going to fill this space by adding 0.2. So the next value after 0, you have to add 0.2. So we have 0.2. Then you add 0.2 again. That will give us 0.4. 0.4. You add another 0.2. So these are the points we have. So now let us construct these rectangles randomly. It doesn't have to be accurate. Something like this. So to compute for the area of each rectangle here, you have to take the base, you multiply by the height. And remember, they all have equal bases 0.2. So let me start with the area, that is the left Riemann sum. For the left Riemann, we have to consider these legs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We stop. For the right Riemann, we have to begin with 0.2 and stop at 2. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be base times the height. What is the base? The base is 0.2. Because we computed it here, it is called dx. What should I write the formula? Let me write it. It will be dx multiplied by f of x1 plus f of x2. You keep on adding this f of x up to f of xn. Then you stop. So let's substitute. This will be equal to 0.2 multiplied by, we're going to take 0 and plug it into the function. Remember, the function is x to the power of 3, right? So 0 to the power of 3 will still be 0 plus 0.2 to the power of 3 will give us 0.008. Then we add, we take 0.4, we raise it to the power of 3. That will give us 0.064. Then we add, we take 0.6, we raise it to the power of 3. That will give us 0.216. We add, we take 0.8, we raise it to the power of 3. That will give us 0.512. Let me continue down here. Plus, we take 1, we raise it to the power of 3, that will give us 1, right? Remember, we are here. Then the next one will be 1.2. 1.2 to the power of 3, that will give us 1.728 plus, then we take 1.4, we raise it to the power of 3, that will give us 2.744. We take 1.6, we raise it to the power of 3, that will give us 4.096. We add, we take 1.8, we raise it to the power of 3, that will give us 5.832. Then we stop here. Remember, we have to take 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to add all of them together. Then we multiply by this 0.2 outside. So this will give us 0.2 multiplied by the whole of this. After I've added all of this, I got 16.2. Then we multiply 16.2 by 0.2. And this is equal to 3.24 in 2 decimal places. So this is the area when we use the left Riemann. Now we are going to use the right Riemann to see and compare the areas. So the right Riemann would be equal to the same base, that is 0.2, multiplied by the corresponding heights. Remember, we are going to start with this one and stop at 2. So we need to compute. Okay, already we have all of this, right? Remember, we started with 0. So now we're going to discard 0 and take all of these values. Look at them here. Then include the last one, because initially we excluded this one. Now we are going to exclude this and include this. So all this remain the same. Let me just copy them. Then plus the last one, this time around, when x is equal to 2, if you plug it into x to the power of 3, you have 2 to the power of 3, which is 8. So this is the last one. So we need to compute for all of this. So if you add all of this together, you're going to get 24.2. So this is equal to 0.2 multiplied by 24.2. So let us multiply them together. 0.2 multiplied by 24.2. This is equal to 4.84. So this is 4.84. So after taking the right Riemann, you see the area is greater than the left Riemann, which is 3.24. So now the last one which I would like to take is the midpoints. Now we're going to take the midpoint, and how can we take them? We take the average between these two. Take the average between these two, because we need the points here, here, and they must be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now let us calculate them. All right, you can see I have attached all the midpoints, and how can we obtain them? You can simply take this, add it to this, divide by 2, it will give you the midpoint. Take this, add it to this, and divide by 2, it will give you the midpoint. But the simplest way to do that, since all the rectangles have the same base, you can compute for the first one, that is 0 plus 0.2 divided by 2, it will give you this. Then keep on adding 0.2 because the base is 0.2. If you add 0.2 to 0.1, it will give you this. Add 0.2 to this, it will give you this after the last one. All right, so how can we compute for the area? The area in terms of the midpoint would be equal to dx, which is the base, that is 0.2, multiplied by, then we take all of these values, one after the other, substitute into x to the power of 3. So let's start with the first one. We have 0.1 to the power of 3, that will give us 0.001. Then we take, let me take this one. Then we take this one, 0.3. We raise it to the power of 3. That will give us 0.027. Then we add. So now let us add all of these numbers together before we multiply by 0.2. And if you compute all of these, you're going to get 19.9. So we have 0.2 multiplied by 19.9. Let's multiply them together. We have 19.9 multiplied by 0.2. That will give us 3.98. So 3.98 is said to be the area when we take the midpoint. But this time around, I'm going to take the actual definite integral to see which area is being overestimated, underestimated, or closer to being accurate. So the actual area will be the integral from 0 down to 2 of the function x to the power of 3 dx. If you integrate this, it will be x to the power of 4 divided by 4, right? Because you have to increase this by 1 and divide by the new exponent. The limit from 0 down to 2. Let's substitute the upper limit. It will be 2 to the power of 4 divided by 4. The minus 0 to the power of 4 divided by 4. This is already 0, so we need to simplify this. So this will be 2 to the power of 4 is 16 divided by 4. And 16 divided by 4 is 4. So the actual area is 4. So let's find out. This is more closer to 4. So taking the midpoint, we are able to obtain an area which is very close to the actual area. Then by taking the right Riemann, can you see that it is overestimated with 0.84? And the left Riemann is underestimated because it is less than the actual area. So the area which is very close to the actual area is what? By taking the midpoint of our Riemann sums. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.